Cool. Oh, yours. Great. Yeah, thrilling countdown.
Yeah.
Okay, hi there. Thank you, Nathan, for having me as a guest lecturer. I'm telling you today a bit about some more modern methods that we've started to use in philosophy, so digital and computational methods. It's a broad basket overview, so you will probably go out with some ideas of ways in which digital methods have been used. And then in the end, after the break, I will present you a specific case of how we've been doing it at Tilburg University. I'm in the History of Philosophy cluster, and we've been developing for about 2 years now a tool for exploring the history of philosophy, learning about particular figures, and maybe also throwing some light on maybe lesser known figures and quantifying some of our grander narratives about what happened in the 20th century philosophy. But before I go to that, some more general things. So the general structure of what I'm going to talk about today is first say something about digitization as a method and as a subject. Those are two things you want to keep apart because a lot of people talk about computers in philosophy, but that doesn't mean that they're all talking about computational methods for philosophy. Then I talk about some applications that have been made. I give you some background on things that have been done, especially what the field of bibliometrics is, which you might not have heard of before. Explain something about what this distant reading phrase means that you might have heard of. And then after the break, as I said, I'll tell you about the tool that we've built, and then after that we also hopefully some time to play with it. Okay, so I mean, philosophy is obviously really old discipline, thousands of years old, and in some ways it hasn't changed very much. It's amazing that texts from thousands of years ago are still relevant. People still study them; they still find use in it. So why care about these very new things? But on the other hand, computers seem to have changed everything, right? There's hardly any part of our lives that hasn't been changed since the invention of computers. Any other scientific field has had some kind of computer revolution. So why is this in the same way happening with philosophy or not? Why do you think this wouldn't be possible? What are the kinds of changes that we should expect? So one obvious way in which computers have changed philosophy is, of course, that people talk about what computers do and what we can use them for, how they change maybe our concepts. At the moment, probably everyone's talking about large language models, what they tell us about intelligence, whether they are agents, whether they raise ethical questions. So these are a lot of the typical questions in which you talk about computers. But also in the philosophy of science, there are important questions raised by computational methods. A lot of climate science, for example, is based on simulations. And simulations are different from experiments. We need to really figure out what we exactly can learn from simulations. Are they in some way analogous to experiments? And so on. So this raises questions for how science works, how we can gain knowledge from these kinds of scientific activities. Then philosophy of language, computers, they work on formalized, explicitly defined languages. We can characterize the different computer languages, their logical power and so on, and how do all these artificial languages relate to natural language? What does it tell us about the way we communicate normally? And then, of course, the standard ethics of AI question, self-driving cars, what happens if algorithms decide whether you get along and so on, and even more. These are all ways in which digitization and computers have become a topic in philosophy, but there are also digital methods. So I want to put all these big questions that maybe get more attention at the moment to one side and focus on the ways in which digital methods have become a tool for doing philosophy. So one of the classical examples, classical here means more than 10 years old. This is, of course, in philosophy terms, all relatively new. One of the ways in which computers have been used is by doing agent-based modeling. So agent-based modeling, take, for example, have you talked about Bayesian belief revision? Probably, I can't understand it. Okay. So you have epistemologists who discuss for a long time about what it is to have rational beliefs about things. Then you realize there's a part of mathematics that tells you what's the probability of something happening based on probabilities of something else. So this is called the Bayesian updating rule. This rule turns out to give you a very good description of what is a rational way to change a belief given new information. So after long discussions, you maybe arrive at a picture for what it means for a person to believe something rationally. But then this is only the story for one person. Scientists are not just this one being that's hovering over everything else, and then they collect information and then find out things by themselves, but there are groups of researchers. If you ever go to CERN, it's thousands of people collaborating. So the question is, how do they interact? How should they interact if the goal is to create knowledge together? And these questions of how should scientists, for example, collaborate to create knowledge, they're not just philosophical questions, but they've long been studied by economists, for example, because politicians, they need to create incentives, they need to make sure that the countries, they foster innovation, that technology can grow. So there are strong reasons that we want to really understand how innovation happens, how scientific research happens, and how we can improve this. So there have long been people developing methods to study this. And then at some point, Kevin Zollman in this case thought, why not use these methods to describe philosophically what the best kinds of social networks should look like if we want to learn the truth about nature. So this model is extremely simple. Extremely simple means extremely idealized, and you might doubt a lot of things. If you think of a group of scientists, they might have an old treatment method for a certain disease, and then they might have a new candidate method. They want to find out which of the two methods is better. So they run different kinds of trials, and the statistical background information they have, they know to what extent success of this trial will increase the probability that the new method is better than the old one. But these things are not entirely reliable. So you might have bad luck. The trial might turn out to be indicating that the method is worse when it actually is better. So you have no absolute guarantees that the result of the trial gives you the final result of what happens. This is sort of this possibility of bad luck is the starting assumption. Now the question is, if you have several scientists, should they include information about other people's experiments and how they learn, how they adapt their own beliefs, or should they work more independently? And in this way, you can think of more connected or less connected networks. So if you have 10 scientists, you can think maybe they should only look at the results of experiments of people directly next to them. So that would be the cycle. Then you can think, well, maybe there should be like one central communicator. One person here in the middle. This person includes information from all the other people around it into updating their belief. And then the extreme version is everyone includes everyone's information. So you think everyone knows what everyone is doing and includes the results of their trials into their own updating of what they believe about the effectiveness of these two treatment methods. So this is different kinds of ways to think about the social structure of rational agents. Individually, they're all rationally. They all follow this statistically correct way of updating their beliefs given the outcomes. But what is different is only whose experiments they take into account when they update their beliefs. Okay. And then the results are not something that Zollman then presents on the basis of some argumentation, but just by running experiments. Experiments, not really the right word, running simulations trying out different configurations, all possible networks in which these 10 people could be connected, and then see how likely are people to miss that something is the better method. So how likely is it that they run into bad luck and don't actually find out that something is a better treatment method? And how fast do they find out that something is the better method if they're lucky? And it turns out that there's a trade-off. So if the scientists are less connected in how they consider each other's experiments, these are the networks we have here. So they only consider their neighbors, if you want. If the person at this end of the graph makes an experiment, this doesn't change, the outcome doesn't change what this scientist here believes. These kinds of disconnected networks are more likely to find out the truth in a way. Because if the person at this end is unlucky, it doesn't mean that this person stops looking for new evidence about this new theory. So there's an advantage of people staying in isolation in some way. But the trade-off that it has is that the cases that are easy to find out, they propagate much faster in these more connected networks. So if something is very easy to find out with trials and people are well connected, they will more quickly all start to agree on what is the more effective method. So there we have a kind of trade-off between the accuracy of what the researchers find out and the speed with which they come to agree about what's the better treatment method. So this is one of the classical cases in which this sort of agent-based modeling has been used as a sort of philosophical argument. Of course, you can then risk, is this philosophy? You will have a lecture about thought experiments as well, and you can think more about how they bear on philosophical questions. And this kind of use of simulations has been offered as a version of giving thought experiments, right? So instead of saying, imagine you're a scientist, but you only talk to your lab mate, and your lab mate only talks to his lab mate, instead of spelling that really long thought experiment out, you specify exactly how it works, how their beliefs depend on each other, and then you run the simulation, and you can get a quantitative answer to how things look if scientists actually change the beliefs in those ways, if they actually communicate in those ways. So, the general idea is that this is a sort of empirical thought experiment that doesn't depend on the ways individual people interpret this thought experiment, but where it's really specified what the thought experiment, if you want, what it really consists in, and then you can openly criticize some assumptions of this model, and use this for very general questions about how scientific research works and how the knowledge of a group depends or influences the knowledge of individuals. Okay. Then this is what I want to say about these agent-based models. Of course, you can make these a lot more complicated, try to make these more realistic, make agents less rational. This is a common criticism, of course, in economics, that the assumptions in economic models are really unrealistic. People have all kinds of non-rational patterns of behavior that can be exploited and so on, and we should probably take that into account. And there's big literature on what this kind of bounded rationality it looks like, how we should model it, and then, of course, the same questions can be asked from a philosophical standpoint. But going from agent-based modeling to working with texts. So the way we normally do philosophy is, of course, we read, we discuss, we write. How could computers change how we do that? We've seen how computers change how we write. I won't say too much about this, but can computers change also how we read? I don't know if you've heard of distant reading. Is that a common phrase now, or is this only in an academic bubble? So distant reading is something that comes from literature studies. It's not going really far away and trying to read from a distance, but it's kind of a metaphor for not going too much into the content of the literature that you're talking about, but talking about some structural features of it. So instead of, so there's literature scholar Franco Moretti, he was researching the evolution of novels, like Pride and Prejudice, much older medieval literature, and then turns out there's so much that giving a commentary on each of them, of course, is impossible, but he wanted to still say something about broader trends, things that happen over a long time across a lot of different books. And one of the trends he found, for example, is that the titles had to become shorter. After observing that, so there used to be a real synopsis of what's happening. The Count of the castle finds his lover and, oh my God, it's his sister. Really strange summaries, but they were too long. They realized when they need to market, it's better to have some kind of short and some kind of enigmatic title that's easier to get people hooked to than a long summary of a book. So after people realized this, the titles of all the novels, they changed sort of together, and he found this pattern. That's a very simple way of describing a lot of literature without going into the detail of what's actually written in there, because it's just a trend about the shape of that literature. And one other thing that he, for example, showed in this distant reading book is if you want to talk about Hamlet and the different roles of people in that play, you can of course look at all the dialogues. You can think about how. Sorry, this is not a very good quality. This is Hamlet. This is Horatio, for example. You could argue, well, Horatio is a really important character in Hamlet because their dialogue in the second act leads to this change and so on, or he's the one who warns them about it. But instead of looking at the details of the text, you can also draw a network of interactions. So you have all the characters in Hamlet here in this network, and whenever there's a scene where one character talks to another, so they have a direct interaction, then you just draw a line between them. And this is how you generate this kind of network. The position here in this case is not terribly meaningful. This is just sort of to make it legible for you. But then it's obvious, of course, that Hamlet interacts with most people. A lot of people have only like one connection somewhere. But then Claudius, for example, and Horatio, they have a lot more connections to other people. So it doesn't always go through Hamlet if they interact with people. They have their own standing in a way. And then one thing that Moretti did was to say, what does this look like if you take out one person? Like, do they still have interactions, all these characters? And it turns out, well, this is still kind of a network because Horatio and Claudius, they also interact, so they keep this whole network together. But the moment you take Horatio, oops, that was wrong. The moment you take Horatio and Hamlet out of the network, it falls completely apart. Because the way that a lot of the minor characters are connected to what happens in the play is only via the interactions with Horatio and Hamlet. In describing this, you've only said something about what you call structural features of the relations between these characters. You haven't had to read a single line of what happens in that play first. And you could say, why should we care? In the end, we want to know what happens in Hamlet. But it's also interesting to find a new way of arguing about how important Horatio is in this play. This is the idea. A way that doesn't require you to sift through the text and find this is a really important moment in the plot. This is where he really sets him off on this terrible course of action. But you can use this kind of method to show there is a sense in which Horatio is really central, because without Horatio, all of these characters are not really connected to the main plot of Hamlet. So this is a way of formally looking at text, this kind of distant reading. In a bigger scale, there's there's kinds of studies that are built on the paratext. So what's the paratext? It's everything that you usually don't read. You have a journal article, you jump right into the main text. You probably don't want to read, for example, the title you might want to read. You probably skip the acknowledgements because these are just as friends. Who cares? Unless you're in it, then it's very nice to see your own name. Or if it's a friend of yours and he doesn't list it, you might get angry. Footnotes on the second read, perhaps. Marginalia, they can sometimes be interesting, but it's maybe not the main meat of the text. So these are just the little notes you have in the margin. Sometimes there's a long scholarly tradition that used to be added to these old books that monks were reading, and they gave them instructions on how to interpret what they were reading. So that this has a long tradition, but it's not a really big thing nowadays. Sometimes if you have an edition of an old philosopher, they might say, here he underlined this with pencil, but we don't know what it means. I studied Husserl, and you often have it, there's a question mark. And then you can wonder what this means. Yeah, somebody's probably written a paper that he changed his mind about something in this year or so. But there's a lot of things to speculate. Anyway, this is not part of the main text. This is part of the paratext. But then, of course, there's this long block at the end of a paper when you're worried, oh my God, this is 20 pages, but then you discover, oh, it's 4 pages of references, it's only 6 pages to read. Those 4 pages are actually super interesting for people who care about the structural features, publications, because they link one document to other documents, right? So the same way that we had here earlier, links between Hamlet and other characters in the play based on how they interact. We have these kinds of interactions between the texts that we read, these relations of citation that we can use to build networks and to do all other kinds of interesting stuff. It even led to a whole new field, or rather 3 fields, which are in a very confusing way mingled up together and have the same origin. Bibliometrics sort of emphasizes that this comes from library studies. Scientometrics emphasizes that this has been used to study the development of empirical science, and infometrics is, I guess some people like the German expression Infometrie, sometimes maybe emphasizing information flow and the internet and so on. What you need to know is not really how they're different, but that there's dedicated fields of study where people look at these relations of citation and how they structure bigger groups of literature that you couldn't just read directly. Like you couldn't read all of the 16th century novels, even if you wanted to. And the simplest metric you can apply to these citation relations is, of course, to just count them. Like who's cited very often, which articles are cited very often, and this is the standard game for a lot of researchers to gain points, and how many people read my stuff, how many people cite my stuff, and it's a bit of a terrible rat race as well, because you might have to justify the impact of your research to people who fund you, and then things like citation carousels, they start growing where people cite each other's work because it's beneficial for each of them. But that aside, just counting who is being cited in a corpus already tells you some interesting things. So this is a one-off little study from Eric Schwitzky. He looked at the Stanford Encyclopedia of Philosophy. I guess you have a lot of set readings that are taken from there. It's a very it's a well-established source. I think also it's very good in a way, like peer-reviewed Wikipedia. But if you care about the kind of representation of people in that corpus, then it's interesting to see that it's a very specific demographic. 85% of the citations in the Stanford Encyclopedia seem to go to white men, another 12% to white women, and the 3%, so this is the small gray bit, that goes to non-white men, and you can't even see this non-white woman, that's one person, that's Linda Martina Alcock. So it's very dominated space of citations, if that's the sort of metric you want to look at, or the classification of these citations you want to go with. Good. So what a citation is, I think, is maybe clear enough. You'll have to learn it eventually when you submit papers or theses, and they will drill down that there's a specific way you have to cite things, otherwise you'll get penalized probably. The idea is always that your document, the source, has to be linked to a target, the article that you've read, or that argues for a claim that you don't want to defend yourself, or anything else that's in some way important to mention within your text. But there's also a concept called a co-citation. So if we want to describe a large corpus, the citations alone, they're very interesting, but there's a limited number of articles that you actually cite in every single paper. The co-citations are a bit more generative. There's a lot more co-citations happening for each single article. So let me just explain what it is. If you have a single article, you cite maybe 20 other articles, let it be 30, sometimes it's 10. So if you just look at the little lines we had drawn between different characters in Hamlet, there's 20 lines you can draw in your big network of articles if you look at the citations. Co-citations, on the other hand, they are links between all the documents that are cited by the same source. So if you cite 20 articles, then between each of these 20 articles, there's now a co-citation link. And this number of co-citations grows much faster than the number of articles that you cite. So it's 2 out of n. It's the combinatorics question. It's n times n minus 1 over 2 co-citation links for n citations. So in the case of 20 articles, you create 20 citation links, but 190 co-citation links. This is useful if you want to have more links to describe in your network. So instead of just having very few lines in your big graph, you can connect a lot more of the articles. And then, of course, articles will be co-cited several times. So you might be somebody who cites Kant and Hegel. You're not the only person who does that. This might be a very common combination. So in a way, you can then start aggregating the co-citations. So it's useful to have more fine-grained understanding of how strongly different authors or different articles are coupled by these co-citations. If you have just more information about these links. Now, when I said this visualization of Hamlet just placed characters somewhere, there was no real mathematically formalized way of placing them somewhere and so on. But if you want to do these studies in a very big corpus, you have so many lines, so many points to place, you need to become systematic about how you do this. And in some ways, you have to make mathematical assumptions. You have to describe mathematically how you're going to place these things on a two-dimensional plane, how you will take into account how strong these co-citation links are. So before I show you what these networks look like, you should keep in mind that you have to assume that some mathematically formulated questions have been answered. So for example, how should we aggregate multiple co-citations between two authors? Between Hegel and Kant, for example, there will be a lot of co-citations, but most of them are also in general quite common authors. If you look at a much lesser known author, he might also be co-cited with Kant, but the reason for that might not be that he and Kant have very much in common, but simply that Kant is cited everywhere. And in some kinds of these network plots, you want to take this into account. There's debates about what's the right way to separate these different effects that lead to more co-citations between authors. Because one of the reasons people are co-cited might be that they're very similar. It makes sense to cite them together because they've done similar work. The other reason might be just that somebody is very prominent everywhere, so it's just being co-cited everywhere. And this might be especially important when you consider Kant. And then, of course, how do we map this whole ball of citations into a two-dimensional surface? These are heuristic questions. There's debates about how to do it. It's not always clear what's the best way to do it. And then you can visually see that some people clump up because they're very tightly connected. This is often useful, but if the network gets very big, you need to formalize how to create these clusters, because it will be too messy to just look at it and say, oh, here's a group and here's a group. In practice, you still have to do this, have to see, do the clusters make sense? But normally you choose an algorithm that decides if points in this network are connected in the right way, then they should be grouped together. So this is the choice of a clustering algorithm that you need to make. Okay, when you have made these assumptions, then you can create networks that are still a bit overwhelming, of course. This might be difficult to read. I wasn't sure about the size. So this is a network of the co-occurrences of philosophers in American philosophy from 1931 to 1940. So the 1930s, in the project we're doing here in Tilburg, we're especially interested in the history of logical empiricism. So I'll talk a bit about that. If you just look at some of the big names, you see that there are some scientists, but they've also written philosophical works, but they're mostly not as scientists. Newton, Einstein, Charles Darwin, Hermann von Helmholtz, Maxwell, Bohr. And one thing that seems that our clustering's been doing something well is that they all ended up in this green cluster, right? There are also some philosophers here. Rudolf Carnap, the logical empiricist, Wittgenstein, Whitehead, C.I. Lewis. They're part of the same cluster. They're very interested in what science is. They discuss science a lot. They end up being cited together a lot with these scientists. They end up in the same cluster. You have some more traditional philosophers, Leibniz, Descartes, Aristotle, Hume. But then German idealism is its own thing. So Kant ends up in a different cluster together with Hegel. Then other German-speaking philosophers like Karl Marx, Nietzsche, they're also in this red cluster. And here's a cluster of pragmatists. But pay attention to Rudolf Carnap. He's here clustered together with the scientists. And so is Hans Reichenbach is another philosopher in this group of logical empiricists. I think you talked about logical empiricism. They're close to scientists. Now, if we look at the network in the 1950s, we have here Carnap, Feigl, Reichenbach. They're still here together with the scientists, but other philosophers that earlier were clustered together with them have now separated from them. There's Quine, Goodman, Russell, Wittgenstein, Sellers, Hume. So there has been developing a kind of separation between these empirically informed philosophers and what we call the maybe analytic philosophers in the UK, the British philosophers. These are the kinds of big trends that you might read about in these overview books for the history of philosophy, and then maybe there's a reference to one or two books, or there's maybe an autobiography by Russell where he describes what happens, and that's then, traditionally, that's the sort of basis you have for making these general claims about what happens in these fields. But of course, Russell hasn't read everything that was published. None of these people have read everything. You might also misremember. it's a very strange way to make these great, grand empirical claims to rely on the close reading of very small things. And the idea is, to say we can only talk about these grand narratives of what happens in the history of 20th century philosophy by looking at such networks, but it's a way to test some stories that people can tell. So if the story is the logical empiricist separated in some way from the analytic philosopher in the United Kingdom, then this seems to confirm that story to some extent. With all the computations that I mentioned about how to define what these networks are. I'll say more about how this was generated in a bit, but just as an example for using network plots for the history of philosophy. Okay, then you had a look at an article about using digital humanities tools. So this is another word for these computational methods, and not specifically for philosophy, but for humanities in general. Using these tools for the philosophy of science, so a sub-branch of philosophy. And the concern there is that, of course, philosophers of science, for a long time, they had a priori thoughts about what is science supposed to be. Let's derive some analytic rules for how we should investigate nature, what all possible scientific theories should be like, but people got a bit more worried about this and wanted to base their view of what science is and how it works on looking at the actual products of scientists. So these philosophers of science were interested in how can we actually study the corpora that scientists produce. There's a lot being published. I mean, philosophy is an overwhelming amount of things to read, but if you compare it to, for example, medicine, the amount of papers being published every single day, it's incredible. There's no way for anyone to keep it up. It only in some way works with extreme specialization and only paying attention to a very, very narrow section of the field, because otherwise it's just too much to do it. So how could we say anything about science in general if there's too much to read even for an oncologist to even keep up with all the things in cancer research? So the digital humanities methods are one way to promise that you can still say something about science in general. The way that scientists publish, they do research, they interact with each other without having this impossible task of reading more than you could fit in 100 lifetimes. One problem you might then face, though, is that we're only looking at a syntactic feature of these publications. So syntactic is just based on the symbols that we use. We see a certain number of symbols appears. They always refer to a particular document. That's why we have a citation here. But people cite for all kinds of reasons, right? You might cite somebody because you know he's on your dissertation committee and they'll be pissed if you don't mention their work. You might cite somebody to then say, actually, this was really misleading earlier studies and now we've done it correctly. Or you might cite somebody because this gave you the final kind of inspiration and without this wouldn't have been possible. So standardly you think that the best citation is, of course, one where you say, the following ideas are completely indebted to this former work and I owe so much gratitude to this person. But in practice, there's blind peer review. There's all kinds of reasons people cite stuff. For example, they want to impress the reviewers by showing, oh, I've read all this stuff. Because how are they gonna, they don't have time to read everything. They want to skim over it and see, could this be a good research paper? And then they realize, you're not citing half the things that come out. This is probably not good work, and then they'll reject it. So you want to avoid that. You cite all of the new stuff that's been published to show them you're aware of all of this. Or you might cite people who you expect to be the reviewers themselves. I'm not telling you to do all of these things, but being realistic, these are reasons for which people cite other work. It's not always that this has been the greatest source of inspiration for why I've been writing this. There's all kinds of mechanisms that lead people to cite stuff. So in this sense, you can have the syntax-semantics distinction. In a way, a citation to this author, citation to Nathan, is probably most likely to be because he has been a source of inspiration without which work couldn't have been possible. Citation to some other people might just be because they're in a powerful committee. They might be the editors of the journal that you're submitting to. I think I would like to look at this quantitatively, how citations to people change when they become editors. We actually found something like that. There's a period in which a French philosopher that I had never heard of was the editor of a very big journal, was highly cited. Everyone talks about him. The moment he steps down from the journal, nobody knows who it is anymore. So there's good evidence that these kinds of reasons are very important for why people add citations. And it seems if you just take them as they are and throw them into these citation networks, you're missing out on all of these different reasons for citing somebody. You're looking only at the syntactic level, at the symbols that you have there in the document, but not at the meaning of these citations. Do you think this is a final nail? Is this in principle reason to be skeptical about using these kinds of methods to characterize literature? Yeah, didn't think I would see.
I know, for example, I know a friend, and she already graduated, but in her thesis, in her introduction, she cited Aristotle just to give the impression that she, I don't know, it gave an impression to her work, but she didn't actually really use content of Aristotle, just in her introduction.
Who was it? Take the degree back.
Tell me the name, I'll have to report this. I think she understood the assignment. Of course, it's sort of a tradition of framing talks.
Exactly.
Yeah, I've seen a talk by somebody who talked about energy policy and renewable energy, and it began with Heidegger's critique of technology. Of course, he then talked about wind parks, and it's sort of a cultural tradition, especially to use philosophers for these kinds of statements. They lend you some kind of depth. I'm sure your friend's case is different. There was depth already, but it's one particular effect that you find is that the distribution of how often people are cited is extremely skewed. I don't know if we can hear. Anyway, so there's very few people who take almost all of the citations that you get. Almost everything goes to Kant, Aristotle, Plato, maybe in more contemporary stuff. Now you have a lot of people citing Williamson, and then because a lot of people cite Williamson, other people think I should cite Williamson because this is really important. I do like Williamson; it's very good work. So it's okay. I'm not going to get into that question, but this is not about saying that it doesn't deserve it, but just the way that these citations are distributed, they always favor very specific papers, and then because they're already the most mentioned papers, other people keep mentioning them as well. Even if it's just to give the impression that you know what's going on, you maybe to show that you're well read, you had a glossary education in Aristotle. Of course, you know that Aristotle talked about.
I really recognized what he said when I was researching for my cultural philosophy paper. At the beginning, maybe I'm doing that wrong, but I do like that. I just search for whatever that's related to my subject because I'm trying to go in a very specific direction, but you need to go a little wrong, and from there I go a little deeper. And then specific chapters, I go like, I'll pick these. And for some papers at the start, they had like a quote, yeah. So I can look at where that quote comes from because probably that really relates to this paper. So it happened at 3 papers. So I picked those 3 quotes and I looked at the sources. And I'm like, what the shit does this have to do with anything they talked about? Yeah. And then I wasted 2 hours. So I hate it.
Yeah, this is a very frustrating experience. I think that a lot of people have this. Maybe effect of this kind of shallow references.
I'm very happy to confess that I have papers where I'm citing papers that I've never read. I'm responding to someone who has cited all of this literature about whatever topic we're about. And so I'm just interested in the person I'm responding to. But of course, we have to be sure that we're talking about the same broad topic. So I'm like, hey, I'm just going to trust that they've actually picked the right things. And I know for a fact that there's at least one debate I've been involved in. There's a reference that's just wrong. Like it talks about, oh, this person has said X, Y, and Z, and they did not. Like went back and actually looked at it, and it's like, no, everyone who's been citing him has just got him completely wrong. And it's just because of this sort of, like, I don't want to waste 2 hours going and reading a paper that turns out to be pointless. So we just sort of inherit. And it's a pragmatic and terrible thing, but it's just the way that a lot of this stuff gets done as it happens. And it raises a huge problem if you're going to try and do the kind of stuff you're after, because that gives you connections when there shouldn't be connections, as it were.
Good. So there's a challenge there, and that is there's different kinds of meanings we have that we can attach to the fact that something is being cited in a certain place. Now the question is what kind of challenge is it? So we're not trying to make assumptions about particular instances of these citations, right? We're not going to one paper and say he cited Nathan here, so that means he's indebted to Nathan. But we're looking at large networks. There's thousands of them. If there's 5 or 6 different kinds of ways in which you can use a reference, all of these ways will be used across the board for everyone. So the idea is that in some way this averages out, and what we might have to adjust, one suggestion in dealing with these problems, is perhaps just how we understand what these citation links mean. We shouldn't assume that they're always the expression of intellectual depth, but they can mean all kinds of, they can reflect all kinds of pragmatic reasons. And also, the networks I showed you are not the citation links, but they're based on the co-citation links. So if somebody cites you without reading you, maybe he's not intellectually indebted to you, but he acknowledges that you're part of a certain debate. That if I'm discussing these authors, I also have to mention Nathan, because Nathan is in this debate. So in a way, this is still a meaningful bit of information, knowing that you have to be cited in this context. And yeah, this is maybe another reason to look more at the co-citations instead of the citations. But I'm leaving these things here for you. We've already spent about half the time. Okay, I'll try to do it in 10 minutes and then give you a break. So much about the citation studies. Think about how much you want to get out of these. On the other hand, it's very useful often to use Google Scholar to find research, right? But they're not completely useless. The question is just what do we make of these counts and the co-citation names? But so we've been talking about the paratext, now the part of the papers that you don't read. Of course, you can also try to use computational methods to process the text, the main meat of the research that you normally would spend staring at. But for that, you need to first think about how you want to represent your documents. So there's no good mathematics for text. I mean, you could say maybe you can add text by putting them together, but what's the average of the text? You swap every other word. So it's not so clear. You have to first decide how you want to represent your documents in a way that you can automatically process them. And that means normally in a way that you can use mathematics with it. And I just want to introduce a very, very simple, but still used model for doing that. So you get an idea of how this works, and then from there you can think of arbitrarily more complex ways of doing that. So this is called the bag of words model. So for example, if you have a review of a movie, this is one of the classical cases where these processing methods have been developed. Say you want to Google for, is this a nice film to watch? Am I going to enjoy this? Or are these two films similar? Google had to process loads of different websites and somehow decide in which order to display them to you. And all of this was already developed before large language models and these kind of new AI systems. That they've changed a lot, but there were already a lot of methods developed that don't rely on these neural networks that are very hard to interpret, but just on statistics about these documents. So one way to get to such statistics is with this bag of words model. You take this text and you just chop it up into all the different words that appear there, throw them in a bag. The order doesn't matter. It's a bit brutal, of course. You throw all the words in there, and then you just count how often does each word appear here. This gives you a list of numbers. And then if you have done this once, for all of your corpus, you can say each line in your big string of numbers, each line represents one of the words that can occur somewhere. So most of them will be 0, because think of all of the English words that you know. In the last paper you've written, you probably have not used most of them. So most of these will be 0. Some of them will be really high. They'll probably be uninteresting. But there are some interesting, like fairy, humor, that will be actually informative about what kind of review of a movie that you've been looking at. Or in the case of philosophy, if somebody mentions the word Kant 200 times, or it mentions transcendental 50 times, this is going to be a different paper from one that discusses maybe quantum physics or explanation, things like that. So you can use these vectors. A vector is just a list of numbers. You can use these to represent your documents in this very crude way. Of course, you're leaving out a lot by dropping the order of things. So if somebody writes, "It is not Kant who discovered that," the not is just dropping out. It's just going somewhere. So this is a well-known reason to worry about this. But if you just want to detect what kind of things somebody's been talking about in the text, this works surprisingly well. Especially if you add some other considerations like dropping out super frequent words and so on, or mapping all conjugations of verbs onto the same. Most importantly, it allows you to use all kinds of mathematics that work with vectors. So you can start talking about the average of a number of documents. You can just add up these numbers and divide by the number of documents you added. You can also talk about the angle between documents. So this is maybe a bit strange, but if you in a three-dimensional space, 3 numbers can give you sort of an arrow, and 3 other numbers, they give you a different arrow, and you have an intuition for what it means that they are at a certain angle. An angle means if you increase the length of this arrow, the angle doesn't change. And you can generalize this to higher dimensions, so you can define angles between high-dimensional vectors. So in this sense, you have found a metric for the angle between documents. And this allows you to, for example, compare very short documents with very long documents, because the total number of words in it, they don't matter. You just want to know, do they point into the same region of words? Are the same kinds of words occurring in both of these documents, or are they opposed? Instead of just using the raw numbers, you use the general direction of this document. And with this representation of your documents, you can then also use some more sophisticated statistical models to represent what the topics are in your corpus. So an algorithm that is what in the computer science context is maybe not ancient, but a classic. So this is more than 20 years old. This is maybe the philosophy equivalent of reading a paper from 1920s. This is an algorithm that is based on a complicated fiction. So you start with this big corpus of documents. You have all the articles in the journal that you're interested in, for example. Now you've created bags of words for them, meaning you have your little vectors, your arrows that represent each document in a way. And then the LDA algorithm tries a fictional experiment. You say, let's assume there are 20 topics, for example, in this corpus. This algorithm then pretends that there are 20 different bags of words from which you can draw words, and you look at what's the most probable distribution of words over these 20 bags to recreate the documents that I found. It's a weird kind of thought experiment, but it gives you a mathematically precise enough way to describe the task and group these documents together, and more than a priori discussion over is this a meaningful thing to do, because obviously these documents have not been created by drawing words out of bags, and the topic is not a bag of words. But this has been quite successful in clustering documents without having to tell the algorithm beforehand that there's this topic called quantum mechanics, here's this topic, German idealism, and these are the words with it. But instead it tells you actually words like these, they often go together, and then you might discover that this is the German idealism topic, or you might discover that there's a topic you hadn't considered. Words that often appear in the same documents, but you hadn't thought about because there's maybe a small topic in your corpus that you didn't know about. So the idea is that you first say how many topics do you have, then you run this algorithm to minimize the surprise in having the documents that you actually have. So what's the most probable way of understanding these bags of words? And then you interpret which words are in these bags, and then those are the topics that you've modeled. In one of the extra readings, there was this paper from Malater who looked at 8 philosophy of science journals and used this algorithm to describe how the topics in those changed. And I also asked you to try and have a look at this online book by Brian Wetterson. He did the whole thing with all of philosophy. And a lot of nice plots and a lot of subtopics, and produced a very big study. With the smaller number of topics, this is maybe easier to summarize. So these are all the bags, but the labels here are something that Malater thought of himself afterwards, after they clustered some words together. And having all of these topics, you can then describe how does the attention to these topics change over time. So for example, there's this very big light brown cluster of philosophy. So these are general philosophy papers. They used to be a lot. They used to make up a large proportion of articles, and then they diminished. This is just a feature of the philosophy of science journal specializing. One of the journals in this corpus is Synthese, a Dutch journal with a long tradition that used to be a very general philosophy journal, then became a lot more philosophy of science oriented. Then other topics, I think what's interesting is language. Here, this teal line, one of the teal lines. It used to be a very big deal to talk about language in philosophy of science. Somehow this has become less of a concern, and other topics like what are arguments and scientific theories, they've become more important. You need a lot of background knowledge to interpret these graphs, but they confirm some larger stories about what was philosophy of science like in the 1940s, what was like in the 1950s, what did people actually discuss. That maybe in the introduction to papers, people often say that something like questions about language used to be really important for any philosopher of science, but this has become a bit forgotten. We want to revisit this now. You might just read over this and say, oh, this is just a sort of rhetoric or phrasing, but in a way, these sort of stories, they keep being repeated, and then they just become common assumptions about it, and we can actually check if this is actually the case. to what extent is it true that philosophy of language was a lot more important for philosophy of science? And it seems like, yeah, there is some truth to it. And then you can also look at the most representative articles in years and use this as a discovery mechanism. And I think that's the last thing before the break I want to use. You talked also about ordinary language philosophy. And of course, philosophers are not the only people who care about ordinary language. There's linguists, right? They have built these massive corpora, all kinds of things that people say in newspapers and online forums, on TV, in parliament, and so on. And they're supposed to be representative of the use of words nowadays. So ordinary language philosophy used to start just from dictionaries, maybe. But now we have these empirical means of looking at how people actually use words. And this, for example, is a paper where two people argue that the way that philosophers of mind talk about experience is very idiosyncratic. Not even all philosophers talk about experience in this way. Experience as this thing that happens inside you, as opposed to, I have 10 years of experience. It's sort of external event that you participated in, but the 10 years of experience is not something that I have to introspect. Not even all philosophers use experience in this way, but it's really the philosophy of mind. So they argue, and outside of philosophy, people don't really talk about experience in this way. They use a random sample, they don't look at everything. But this is a way of having new methods combined with some old method, perhaps. So if you're interested in ordinary language philosophy, this is probably an exciting time because you have a new way of checking some ideas that go beyond just using big text. And then, the provocative question is, of course, to what extent is this still philosophy? Is this not studies about philosophy, what philosophers are doing? So you could think maybe this is at the best sociology, something we should know in the background. And at worst, you could think Feynman said something similar about philosophy of science. You could worry that digital methods are as useful to philosophy as ornithology is useful to birds. I don't think so, but you'll have a break.
So why don't we take a break until the hour? So 12 minutes or so? Yeah. Come back again. Wow.